Welcome back. So in our previous lecture we have discussed about what is the basic principle behind the GPR technique and different components of GPR, the penetration depth of GPR, and now I will be discussing about how we can acquire the data into the field. So currently we will do a 2D profile. So it is very important before getting into the 3D profile. It is very important that we should take several 2D profiles to get the overall idea of the region, so that we can accurately decide the 3D grid where we have to take the data, where we have to map the subsurface, near subsurface region. So so now as you can see we have adjusted the parameters. So now as you can see we have adjusted the parameters. The mode is 2D, and now we will just click on the start scan. So we will be taking a profile of around 10 meter from here. So we will take, there is a vacant space, a chamber is there, vacant chamber is there within the subsurface. So we will try to target that currently. So we will take a 2D profile while going from here and while coming back from here, so from there. So there will be two profiles, so that we can correlate the data of both the profile, and we can verify that if the data is not due to some any other kind of noises or any kind of another feature. So we will take two profiles while going from here and while coming from back from there. Now as so I will you can start the profile by pressing the start scan. So you can see now the real time mapping of the subsurface has been stopped, and you can see this is the horizontal distance, that is the distance of the ground that we can see. This is 0, 1, 2, 3, 4, that will be the data that we will be acquiring while creating the while taking the profile, and this is the depth. Depth we have taken it up to the 4 meter. So now I will, you have to always keep in mind that you have to push or take the GPR unit very slowly, so that the transmitted and the received data can be catched by the receiver. Otherwise if you will move it very quickly or fast, then the transmitted electromagnetic waves will not be able to detect by the receiver. So it is very important that you move very slowly while taking the GPR survey. So now I am just, so now you can see as I am moving the the cart, the data is being acquired. As I am moving the GPR unit, the data is being getting acquired. So this is the real time data that you are able to visualize, and as we will cross this chamber, you can see. So as soon as we have crossed the vacant chamber, you can see that this is the portion where the empty chamber is present. You can see in the screen that whole part, this air filled chamber that is vacant, that is shown by a black region throughout the depth. So we will repeat the profile by taking it once again in the reverse manner. So I will stop the scan here. Here where there was the start scan, there is also a tab of stop scan. We can I will press this. So this profile has been stopped. So we have taken one profile while coming from the initial point. it is very important that you should mark the initial and the final position while taking the profile. So now I will play back the profile that we have taken. So we will click on the playback mode and you can see that we have taken one profile. So I will check, I will check on this folder and press the tick button. So you can see the overall profile has been taken. So from there, from the initial point to the final point, it is around of 9-meter profile, and at the horizontal distance of around 5.2. So if you will touch the screen, so you can just the crosshair will be shown, and you can easily know the depth and height, depth and the horizontal distance that you want to see. So the horizontal distance from the initial point is 5.15 for the this airfield chamber, and the width of the chamber is around 3 meter approximately. And other than the chamber, we can also identify few other utilities. So as you can see, there is a hyperbola that is getting that we can see over here. So you can see a hyperbola, that is this is the hyperbola. So this hyperbola actually gives the signature of the underground pipe that we can encounter. So similar hyperbola we can also find here. This is also a hyperbola, which is also for this we can also interpret as a pipe. So there are two pipes that I can see as of right now, and there is a gas filled chamber. The hyperbola signature for the cylindrical pipe is so the logic behind the hyperbola signature for the cylindrical metallic pipe is that when the electromagnetic waves propagate from the pipe. So suppose this is our cylindrical pipe and we are crossing the GPR unit across this. So the electromagnetic waves at the side of this pipe will take the higher time duration than the central portion. So this will take more travel time to reach to the receiver, and the crest part of the pipe will take a short time. So the travel time is based on the travel time, you can get a hyperbola symbol on the radargram. So that's why we are getting a hyperbola signature for the, we can interpret as a hollow cylindrical pipe within the radargram, and this is the chamber that we can encounter. So now I will repeat the same profile while going from the final position to the initial position, and the profile that we will correlate from the profile that we take previously. To confirm the presence of the utilities. So I will stop the playback, and now we can go to the collect mode. So we will get back to the collect mode in which we can acquire the 2D data. So this is collect mode. So you can see that now a real time data will be taken through this mode. So now as soon as I will press the start scan, the scanning scanning will be for the 2D profile will start. So gently, slowly I will take the unit and I will move it at the same path that we choose. So now you can see on the display once again the hollow chamber has been encountered. And till here the chamber was there, and it has been now over. So you can, as I have seen that while taking the profile also, you can see that there is a hyperbola that is coming. So we can mark the position over here for the interpretation part, that we have encountered a utility pipe over here. So we can mark the location here by putting some color on the ground, or we can mark it manually. And now I am moving further away. So the total profile was around 9 meter, and similarly the second hyperbola has also arrived here. So that means in both the profile we are getting the correct data. So 9 meter has been completed. So I will stop the scan. So we have taken the second profile. So to access the second profile, we will once again go to the playback mode, and you can see a second profile has been generated over here. Second file has been generated, and so there is a checkbox that we have to select, and we have to click on this part. So you can see, to go to the full screen, once again you have to click on the playback file. So you can see the chamber was there over in this portion, and so the profile total was of 9 meter that we took while going from the initial position to the final position, and the chamber that we encountered was from 5 meter at the horizontal distance from the initial point from the first profile. And so by back calculating, it was around 3 meter. So our chamber was from 5 meter to 8 meter in the initial profile, and from by looking at that, the profile should start at 1 meter from here. The chamber should start from 1 meter, and it should get over at the 4 meter. So as we can easily see that it is starting from 1 meter, and it is getting over at 4 meter. And other than that, we can clearly see the hyperbola structure over here and over here. So similar kind of profile has been generated. So that means the noise value of the signal that we have encountered, that is from the utility and not from other kind of noise. So now I will show you how we can see how we can acquire the 3D. So we have done the 2D acquisition of the data. Now we will acquire the 3D data using the 3D mode, which I have mentioned earlier. So to go to the 3D mode, I will just stop playback, and system options, then system shutdown, and I will close this application and go to the start screen. So this will close our 2D data profiles, and now we are back to the start screen. So once again I will press A1, and I can change the mode using this tab. So initially it was 2D, now it is 3D, as you can see. And now I will create a new project, and I will create a new data path and give it a name lab practice 3D. So now you can see the file has been generated, and the name of this is lab practice 3D grid 1. So we can take several grids. So I will design a 3D grid for our 3D data acquisition. So signal process is same as 2D that I have discussed earlier. We have to just define the 3D grid. So you can see there is one mode that has been added over here. So I will go to the 3D mode, and in 3D mode we can configure the grid. So you can see that we have to configure the grid. So this the grid mode, that we can see that there is x start, x and y start, y end, and the spacing between the x line and the spacing between the y line. So what we can imagine is like, so for 3D mode, what we can imagine is a grid like a coordinate system, a two-dimensional coordinate system, in which we have x coordinate and y coordinate. So suppose if we want to create a grid of 2 by 2 meter, so for that, and the interval for each meter should be the offset between the grid should be 1 meter. So the grid size will be, we will give the x is equals to 2 and y is equals to 2, and the offset will be of 1 meter. So it will create a 2 by 2 grid with having a mark between 1 meter. So that is the spacing, that is how it is getting configured. So I want to create a 2 by 2 grid. So x start will be 0, x end will be 2, y start will be 0, and y end will be 2. So now you can see the system has generated a 2 by 2 grid having a spacing of 1 meter. The x spacing and y spacing is 1 meter. So as you can see, this is the 0 0 coordinate. That means x is 0, y is 0 over here. So we have configured the 3D grid of 2 by 2 meter having a spacing of 1 meter on the system, and similar kind of grid we have also marked on the ground. As you can see, this is also a 2 by 2 meter grid having a spacing of 1 meter in x and y direction. So now we will keep this unit on the initial 0 0 position, and it is very important to know that the initial point always should be correlated to this point. This is the initial starting point of the profile. This mark has been given. So this is the center point of our transmitter and the receiver. So our profile should always start from this point and not from the initial of the cart, but it should be from the center point of the cart. The mark has already been given on the cart. So I will adjust so that our central part is matching with the marking, and we will start the scan. So as soon as I will start the scan, it will show that we are going to cover this part of the profile. So as soon as I click on the run pad, so run tab, so it will, you can see the profile is getting generated. and as soon as 1 meter will be completed, this 1 meter has been completed, and we can correlate it with the ground also, and as soon as the 2 meter will get completed, it will automatically get over. So now you can see this profile has been taken. We have taken one grid. So now I will go to the second position. So now I have moved the unit to the our second profile, and I will press the run tab, and it will start taking the second profile from the x direction. So now it has been completed. Now initial I will once again take the profile to the final x position, and I will press the run tab. So it will take the we have completed the x direction profiles. Now I will get back to the 0 location of the profile. So now we will take profile in the y direction. So now the y direction profile is being shown. So as soon as I have brought the unit to the 0 initial location. Now we will take the profiles along the y direction. So as you can see in the screen, the y direction has been now shown. So now we will press the run tab, and this profile is getting captured. So one profile has been taken. We will get back to the second Y position and press the run tab. So this will start taking the second profile, and now we will take the third and final profile, which will complete our 3D total grid. So I will press the run tab, and so now we have seen that we have taken the till now we have taken you can see over here that in the grid 4 total 6, in the grid number 4 total file number are 6. That means we have taken 6 files. So I will go to the playback mode, and we have we have taken the data into the grid number 4. So we will select it, and as we can see, there are total 6 profiles that is getting loaded, and you can playback files. So individual files you can go you can select. So this is file number 1, and next file, this is file number 2, next file number 3, next file number 4. Similarly, we can see that we have taken 6 total files of 2 meter each. So now I will go to the playback mode. Now if we want to see the overall animated profile, so we can go to the Z slice, and we can it will get load, and you can see that overall profiles that has been taken, it has been it is now you can see from 0 to 2 meter it is getting vary, and from 0 meter to 2 meter it is getting animated on the screen. So you can visualize the data, and you can also you can also take the x slice or as we have taken the Z slice, we can also take the X and Y slices. We can animate the X and Y slices. So if you want to go to the Y slice, you can see, so you can animate all the layers using this. Similarly, you can go to the X slice, so you can see all the profiles are getting animated, and you can visualize the same individually and using the grid mode. So we have seen how we can acquire 2D and 3D data through using the GPR technique, and you can easily detect or image the near subsurface region up to a depth of 4 meter. And if we will reduce the frequency, so there are other units that is of 100 megahertz and 200 megahertz. From that you can attain a depth of around 20 to 30 meters, and similarly you can go to the deeper level of the data. So now further we can also process the data using the Radan 7. So if time will be there, so we will also show, if there will be time, so we will show you how we can process the 2D and 3D data on the Radan 7 software to reduce the noise and to enhance the data. So I will stop here, and we will get back to the next lab.